400 billion stars out there, just in our galaxy alone. If only one out of a million of those had planets, all right? And if just one out of a million of those had life, and if just one out of a million of those had intelligent life, there would be literally millions of civilizations out there.
Well, if there wasn't, it'd be an awful waste of space.
But if life is common in the galaxy, what kind of life would it be?
Welcome to Planet Adro. I'm glad you made the journey.
A Goldilocks zone planet, 3 times the size as Earth.
My planet is mostly an ice planet, supported by a thick 200-kilometer atmosphere. Although it is rocky underneath its icy surface, the temperatures are about -3 degrees Celsius. Despite this being cold and icy, life still exists.
Based on what we know about Earth, the fundamental cocktail looks like this. You need liquid water, the right atmospheric gases, and, if you're lucky, specific global signs of life.
So the search for life starts off following water, following carbon. Not because we can prove that that's the only way to do it, but because that's the only way we know how.
We have a concept for this. It's called the habitable zone or the Goldilocks zone. And the basic idea is you can't be too hot because otherwise you'll lose your oceans. They'll basically boil and steam away. You can't be too cold because then your oceans will freeze over. You want that big sort of global ocean reservoir at the surface, which happens when you're kind of in the middle and just right.
Smaller than the gas giants, but larger than Earth, super-Earths are terrestrial and made primarily of rocky or icy material.
The topography of my planet is quite similar to Earth, except for the fact that there is less life. You can't hear the birds that you can hear in the background here, but you can see layers of sedimentary rocks with different oxidization levels, indicating that there is an atmosphere in this planet.
The most important requirement for life is liquid water. And that's the defining requirement for life in terms of our solar system. There's plenty of energy, there's plenty of carbon, there's plenty of other elements.
Liquid water is crucial because it's an ideal solvent. Molecules can easily move around in it and react with one another, allowing the complex chemistry of life to do its thing.
We're on the Goldilocks planet.
Life is turning up in some of the coldest, bleakest conditions imaginable. So now that we've found life, not just surviving, but thriving just about everywhere.
Planet Adro.
With its special attributes of size, chemical composition, temperature, a stabilizing moon, just the right amount of water as a veneer on the surface that allows the continents to poke out, those planets may...
Microbes that can thrive in deadly conditions. Alien properties. The ability to form DNA molecules using arsenic in the place of phosphorus.
And we call these very low-mass stars M-dwarfs. Our sun is yellow in color, very massive, very large, and compared to it, these low-mass M-dwarf stars are tiny. They're only about 10 or 20% the size, 10 or 20% the mass, and they only put out 1/1000th the amount of energy.
M-dwarf stars, also known as red dwarfs, make up over 3/4 of all stars in the universe.
An M-type star provides much less sunlight than our star. To get the same amount of warmth, just like this dimmer fire, you have to move in closer. There's still a habitable zone. You can get close enough to the star that it's warm enough for liquid water.
The probability of intelligent life evolving on another planet is perhaps the greatest unanswered question. New planet hunters will take up the quest, exploring the age-old question, are we alone?